Welcome back. In the next part of this lecture, we'll be talking about doing multiple transformations on a basic shape. So not just a stretch or a reflection, but doing maybe all of the different transformations. The first part that we'll need to be aware of is that when we've got multiple transformations that we're carrying out with a function, the order that we carry them out does matter. And some of this is really related to our order of operations. If you're thinking about something like, for example, y equals 3x squared plus 2, and if you're thinking about the order of operations here, that if I gave you a value for x, and I said, could you please tell me what the value is for y? The first thing you would figure out is, well, what is x squared? Then you'd figure out what 3x squared is after that. And then finally, at the very end of it all, you would add 2, because, of course, for the order of operations, addition and subtraction, that's done last. That means that if we're thinking about our transformations, the first transformation, the vertical stretch, is happening before we do our vertical shift. So this is what I mean by the order of the operations and the order of the transformations matters. In general, the order that we'll be carrying them out for this course would be doing anything that's horizontal first, the horizontal stretches and the shifts, so dealing with all x-coordinate things, then dealing with the vertical, and dealing with them in the order of doing the vertical stretches and flips first, then doing the vertical shifts last. So something to know is that at this point in the course, you might have a vertical stretch or you might have a vertical shift, but you're not going to have both at this point. When we do get to trigonometry and graphing trigonometric functions, we will be looking at, though, both things happening, having a graph where you might be compressing it in the horizontal direction and also flipping it, let's say, and maybe also shifting it. You might be doing all three things. But for right now, we'll either be shifting things horizontally or we'll be stretching and flipping them. We won't be doing both yet. So that means that when we're looking at a function now, we're going to need to, number one, be able to identify all the different transformations that are going on, and then think about the order in which that we're going to carry them out. So for something like this function y equals negative 2 times x minus 1 squared plus 1. Just to look at this a little closer here, there's 3/4 transformations that are really happening. Our first transformation is one where we have x minus 1. That's an amount being subtracted just from the x's. We know that that means it's a horizontal transformation. In this case, it's a horizontal shift, and it's a shift of 1 unit to the right. Then next, the squaring function itself is all being multiplied by negative 2. That's a vertical stretch by a factor of 2, and it's also a vertical flip. Finally, our last thing that we would do would be the adding 1 at the end. That's our vertical shift, our going up by 1 unit. So when I'm graphing this function f of x, I actually will need to graph it 4 times. I'll start off by graphing the basic shape, then graph with the first transformation, the horizontal shift, then I'll graph with the vertical stretch and flip, and then finally I'll graph after I've applied that vertical shift, and that will be the entire function that I wanted. And of course, just like always, all of these graphs that I do will all be well labeled. So I'm going to make sure that when I do all 4 of these, that I'm labeling my axes, labeling my tick marks, labeling my points, and labeling the equation that I've graphed. So I'm going to do this function here, y equals negative 3 x minus 2 plus 1. And so you can see that we've got several transformations to happen here. We're shifting it to the right by 2. That's the minus 2 going on. We have a vertical stretch by a factor of 3 and also a flip. We also have a vertical shift. So we've got 4 graphs that I'm going to graph. The first one being just the basic shape, y equals absolute value of x. And we know our points for y equals absolute value of x, 0, 0, 1, 1, negative 1, 1. And now let's just label that. And there we go. So that's our first graph, y equals absolute value of x. That's our basic shape, a nice well-labeled graph. And now the next thing that I'm going to do is carry out my first transformation, and that would be my horizontal shift. The x minus 2 is telling me that we're going to be shifting our graph 2 units to the right. So the graph that I'll be plotting here will be absolute value of x minus 2, and I'll graph that by taking all of my points and moving them all 2 units to the right, adding 2 to every x coordinate. So the first point, negative 1, 1, when I added 2 to its x coordinate, I got 1, 1. 0, 0, when I added 2 to its x coordinate, I got 2, 0. And then 1, 1, when I added 2 to its x coordinate, I got 3, 1. So just adding 2 to every x coordinate for all of my points. And again, the points that are on the x-axis or the y-axis at a tick mark, I don't need to give a label for them. So in case you're wondering why 2, 0 is not labeled, that's why. If you do want to label it 2, 0, you certainly can. You're just not required to. The reason being is that it's obvious enough that that point is at the point 2, 0. So we've done our first 2 graphs. We've got the basic shape. We have done our horizontal transformation, our transformation to the right by 2. And the next transformation that we'll do will be the vertical stretch and flip. And we do that by multiplying all of our y coordinates by negative 3. So when I graph the next part of my function, it'll take what we just did, the horizontal shift, absolute x minus 2, and we're now going to do the vertical stretch and flip. We're going to multiply all those y coordinates by negative 3. So the graph that I'll be plotting here will be y equals negative 3 times absolute value of x minus 2. And I'm going to take all of my points that I had from my previous graph and multiply all their y coordinates by negative 3. The point 2, 0, multiply its y coordinate by negative 3, and it's still 0. For the point 1, 1, multiply its y coordinate by negative 3, and you get the point 1, negative 3. Same thing with the point 3, 1, multiply its y coordinate by negative 3, and you get 3, negative 3. And let's just label that. There we go. Points nicely labeled. And the last thing that we need to do is now carry out our vertical shift. If we go back, we'll remember that there was one last transformation to do, the little +1 that's at the end. That's a shift upward by 1 unit. So that means that now I'm going to take the last graph that I have and I'm going to shift everybody up by 1 unit. So that will give me my graph of f of x. So I'm just going to label my graph before I plot it. There we go. We're going to take our points and we're going to shift them all up by 1, which means adding 1 to every y coordinate. So 2, 0 shifted up to 2, 1. 1, negative 3 shifted to 1, negative 2. 3, negative 3 shifted to 3, negative 2. And then I just need to finish things off with a little bit of labeling. There we go. And there I've got a nice, well-labeled graph of f of x. And so this is what I expect to see if we are going to graph something by transformations. That will start with our basic shape, and then we will do our transformations one at a time, and each time giving a well-labeled graph, carrying out all the transformations until we have our final transformed graph. And there we go. That's f of x equals negative 3 times absolute x minus 2 plus 1. All right, let's do another one here. So I've got a function where I haven't given us the equation, but I've described what's happening. So g of x is our parabola, y equals x squared. We're going to shift it to the right. We're going to stretch it vertically. We're going to reflect it in the x-axis. And then we're going to shift it upwards by 2 units. So to start with, if I'm thinking about g of x, it's the squaring function. But the first thing that we say is that we're going to take our function and shift it to the right by 3. And we know that what that means is that we're going to be then having, instead of x being squared, it should be x minus 3 being squared. That would be a parabola shifted to the right by 3. But of course, if we also want to stretch it by a factor of 2, then this function needs to be multiplied by 2. And if it also wants to be reflected in the x-axis, then really not just 2, but rather negative 2. That will do the stretching vertically and the reflecting. And then finally, we have a shifting upward by 2 units. That would be plus 2. So this function that I've created, g of x, that is the squaring function. It does have a shift of 3 to the right. It has been stretched vertically by a factor of 2, and it has been reflected in the x-axis and also shifted upwards by 2 units. So that's the equation that we'll want to be graphing here. I'll start, of course, with my basic shape, my parabola, y equals x squared. And as always, labeling all of the points that I've plotted, making sure it's a nice, well-labeled graph. So there we go. That's y equals x squared, our parabola going through negative 1, 1, 0, 0, and 1, 1. And our first transformation was to shift it 3 units to the right, which means adding 3 to every x coordinate. So we'll do that now. So adding 3 to every x coordinate means that I'll have the points 4, 1, 3, 0, and 2, 1. There we go. So our first 2 graphs are now done. The next part that we'll need to do is to carry out our vertical stretch and flip. And that was vertical stretch by a factor of 2 and also flipping it in the x-axis. So we're going to take our graph that we've just done and we're going to multiply all the y values by negative 2. So the point 4, 1, multiplying its y coordinate by negative 2, you'll get 4, negative 2. 3, 0, its y coordinate is 0, it'll stay 0. The point 2, 1, multiply its y coordinate by negative 2, and you'll have 2, negative 2. So we've stretched it, and we've flipped it. So it is now 2 times taller than it originally was, and it's also now pointing downward. So that's negative 2 times x minus 3 squared. That's our second transformation and third transformation done at the same time. And then finally, the last transformation was shifting it upwards by 2, adding 2 to every adding 2 to every y coordinate rather. So that means that we'll now have the points negative 2, 2, negative 2, shifting it upwards by 2 gives me 2, 0. 3, 0, shifting it upwards by 2 gives me 3, 2. And 4, negative 2, shifting it upwards by 2 gives me 4, 0. There we go. I'll just label that point 3, 2. And then the last thing to do, of course, is label my graph. That was g of x being negative 2 times x minus 3 squared plus 2. All right, let's do one more. So here I've got a function. It's my cube rooting function. And I can see that there's 3 transformations. I have x plus 1, that's telling me that we'll be shifting it to the left by 1 unit. So I'll be subtracting 1 from every x coordinate. I'm going to be stretching it vertically by a factor of 3, multiplying every y value by 3. And then I'll be shifting it vertically by a factor of, shifting it vertically by 2 units. I'll be adding 2 to every y coordinate. But of course, as always, we always begin with our basic shape, the cube rooting graph. The cube root graph looks kind of like this cubing function y equals x cubed turned on its side. It has exactly the same 3 nice points as y equals x cubed. That's negative 1, negative 1, 0, 0, and 1, 1. There we go. That's our cube root of x function. And we're told that we want to first graph this function f of x, 3 cube root of x plus 1 plus 2. And the first thing that I'll need to do is to do that horizontal shift. It's a shift of 1 to the left, so I'll be subtracting 1 from every x coordinate. So the point 1, 1 will now be the point 0, 1. The point 0, 0 will now be at negative 1, 0. And then the point negative 1, negative 1 is now at the point negative 2, negative 1. And there we go. We've got our graph of cube root of x plus 1. So our cube root graph that's now been shifted 1 to the left. And then the only things left to do now are our vertical shift and our vertical stretch. We'll do our vertical stretch first, so multiplying all of our y coordinates by 3, and then we'll do our vertical shift after that, adding 2 to every y coordinate. So let's do the vertical shift first. We're going to multiply all of our y coordinates by positive 3. So the point 0, 1, multiply its y coordinate by 3, we'll get the point 0, 3. We had the point negative 1, 0. And we've also got the point negative 2, negative 1, and we multiplied its y coordinate by negative 3. That gets me negative 2, negative 3. And so there we go. We've got our graph of 3 times the cube root of x plus 1. And you can see, comparing it to the previous graph, that it is 3 times taller than the original graph was, stretched vertically now by a factor of 3. And then the last transformation that we were going to do was to add 2 to every y coordinate. The last thing was plus 2. So we're going to take all of our points and again add 2 to all of them. Looks like I'll need another tick mark here. There we go. Because that point 0, 3, when I shift it upwards by 2, it'll now be at the point 0, 5. Negative 1, 0, shifting it upwards by 2, it'll be at the point negative 1, 2. And then finally, -2, -3, shifting it upwards by 2 gets me to the point -2, -1. And let's do some labeling here. There we go. So I've got my points -2, -1. I have my point -1, 2. And I've got my point 0, 5. And that's my graph of f of x. 3 times cube root of x plus 1 plus 2. All right, and now finally, we're going to be taking a function that's not one of our basic functions and transforming it. I won't actually be graphing it, but I do want to come up with an equation that describes this. So I have f of x given to us. It's x plus 1 over x minus 3. And I want to know what would be the equation for the graph of that function after you've transformed it by shifting it 2 to the right and also shifting it down by 1. So in order to do this, this is where I'm going to need to remind myself of some things at the beginning where I said symbolically, how did we represent something that was a vertical shift or a horizontal shift. So if you're remembering back at the very beginning of things, I said that if you had a function plus a number that represented a vertical shift, and f of x minus a number that represented a horizontal shift, I'm going to be doing the same sort of a thing here. I'm going to be thinking in that sort of way to express this idea of f of x that's been shifted 2 to the right and shifted down by 1. I know that if I were to take f of x and take that entire function and subtract 1 from it, that would represent taking my function and shifting it down by 1. That was how we had defined vertical shifts. F of x plus k was a shift up. F of x minus k, that was a shift down. Also, I want to shift it 2 to the right, and we know that if you were to take the x values and have them replaced with x minus 2, that would represent a shift to the right. Just like how x squared versus x minus 2 squared, this is the graph of x squared that's been shifted 2 to the right. So when I think about my function f of x, and I want to think about it being shifted 2 to the right and then shifted down by 1, that really is f of x minus 2 minus 1. Now the next part here, you might say to yourself, well, okay, that's fine and good. What does that give us as a function? Well, if we want g of x to be our function f that's been shifted 2 to the right and then also down by 1, we'll need to figure out what f of x minus 2 is. And we know how to do that. If you're thinking back to the beginning of chapter 3, that's take your function f of x and replace all the x's with x minus 2's. Which, if I were to clean that up, that's x minus 1 over x minus 5. And I can simplify that a little bit further. Just to combine those two terms, the minus 1, I could rewrite that as x minus 5 over x minus 5. And then cleaning things up, we would finally have in the numerator 4 over x minus 5. And there we go. So if you were to graph f of x, and if you were to graph g of x, if you were to graph this function and that function, you would see that they look the same, except that g of x is f of x after it's been shifted 2 to the right and shifted down by 1. All right, so next we had g of x, and now we want to create h of x. h of x is the function that we get by taking f and stretching it vertically by a factor of 2. And so we know what to do here, that h of x should be found by taking f of x and stretching it by a factor of 2, and a vertical stretch is when we multiply the entire function by a constant. So h of x should be 2 times f of x. And again, we know what f of x is. That's x plus 1 over x minus 3. And so h of x should be 2x plus 2 over x minus 3. So if you were to graph h of x and graph f of x on the same axes, you'd see they look very similar, the only difference being that h of x is twice as tall as f of x.